Okay, in this video we're going to be answering the burning question, why is it that only 1-1 functions have an inverse? To begin with, we're going to think about our definition of a function. We know that a function requires that each input has exactly one output. Let's look at a mapping diagram of something that's not a function. Here we have an input A that's giving us two outputs, P and Q. So although we can say that this is a mapping, because one input is giving two outputs, this mapping does not represent a function. Let's see how that causes problems when we try to do an inverse of a function that's not 1-1. So suppose we have a many-to-one function f. That would mean we've got two input values, we'll call them A and B, that would produce the same output value, C. So on the mapping diagram, we could represent it like this. That's perfectly fine. There's nothing to stop us having a many-to-one function. However, the issue arises when we then try to define an inverse, because our value C has to get us back to both of the original values of A and B, which means we now have a one-to-many mapping, which is not a function. And so the only way we can get around that is to make sure that we start with a 1-1 function, because then the inverse will also be a 1-1 function.